BMW E46 turbo build. In today's video, we are going to install this bottom mount turbo manifold, modify, then install this turbocharger. We will also be installing this E39 oil pan. Turbo manifold. We are going to use a SPA bottom mount turbo manifold. It can accept both T3 and T4 size exhaust housing turbos. Back here is the wastegate location, which I blocked off simply by making my own little block-off plate here. I like these manifolds because they come pre-cut in between each runner. They also come pretty well port-matched to the gaskets, as you can see there. During installation of this to your engine, you can use gaskets of your choice. I'm going to use this style gasket right here. They are individuals. Anything besides these right here, these are junk. They will blow apart. They are typically included with a lot of aftermarket applications. And there we go. We now have the manifold installed. As you can see, this engine used all 24 of the stud and nut locations. Some engines do not, so that's nothing to worry about. To make your life easier during installation of this, I'm going to show you the tools that I used. Using ratchet wrenches, both the regular length and also a stubby short length. This right here is a offset wrench. Comes in handy big time for installing those nuts. It gets right up in there. It works beautifully. And then your typical 1/4-inch ratchet with various extensions and sockets. Now, this one I actually bent the handle on a little while ago for doing exhaust manifolds just for these cars. This also worked really well to get access for some of those nuts. Okay, so here is the turbocharger. I have removed the exhaust housing from it. As you can see, right here is the turbine wheel, which will receive exhaust gases. That is what spools the turbo. Meanwhile, here is the exhaust housing. There is a giant hole which has been cut into it. That is because I'm going to be putting the wastegate directly on the turbine housing. As you can see right here, there's a straight shot right to the opening. This right here is where those exhaust gases will be entering the turbo to spool it up. Look at that straight shot out to the wastegate port that I cut. See that? So whenever you mount your wastegate, which is this right here, directly to the turbine housing, that is a very efficient way to control your boost levels, as long as it's done properly, that is. Using a 40mm precision wastegate, this is what we chose for this project. So long story short, a quick rundown of these things. They take springs and they are controlled directly from the boost pressure. Allow me to show you inside real quick. Here is a big diaphragm. This port down here will have a boost reference to it, okay? So up here, you put a spring into the wastegate. Let's say the spring is rated for 8 pounds of pressure. An 8-pound spring will be in here, it's compressed, which holds this valve shut. See this valve right here? It's going to hold that valve shut with 8 pounds of pressure from above. Whenever the turbo produces 8 pounds of pressure, this port will receive that boost pressure, which directly is going to raise up the diaphragm and compress your spring, which will then fling open that valve in there. And then exhaust fumes will rush out of this exit port here. Then you have this port on the very top, which is a simple vent port, or it can be used for boost controlling. So I'll be taking the wastegate and I'll be welding on this pipe right here, which is a chunk of 90-degree 1 3/4 diameter with a 3mm wall thickness. Pretty thick metal here. This will get welded directly to the wastegate. I currently have the mounting flange attached to the wastegate with this clamp right here. That is because whenever we weld the wastegate to this pipe, that flange has the possibility to warp if it was not clamped. So once this pipe is welded on, we will unbolt the wastegate and then weld this directly onto the turbine housing like that. If you want to do something similar, you must make sure you have the hole an adequate size, or you can possibly have a boost creep, meaning the turbocharger will boost past your target PSI range. When it comes to welding the turbine housing, This one is made from a cast material. It is going to be cast steel, which requires certain steps to weld properly. We will show you the process of how to properly weld cast. Okay, so here we are back at the shop. As you can see, we have the welding completed. Turned out pretty good. We were both surprised with how well the cast steel actually took to welding. As you can see, we got good penetration and everything. Turned out pretty nice. Now, we need to further modify the turbocharger by removing the compressor housing, cutting off a chunk of it like this, and then we're going to weld on a elbow, which looks like this. Also, cutting off a chunk from it, right here, we are going to weld these together to help us clear the front subframe when it comes to the intercooler piping. Okay, so here is the turbocharger complete. It is ready to be installed. We got this piece here welded on. You can see right there it's welded. We also have this offset coupler installed. This is going to help us get over the subframe. The wastegate is also mounted on there. Along with the boost reference hose going right to the wastegate, it is a high quality silicone which has been heat sleeved so it can withstand the extreme temperature from the turbo. I also added this little bracket right here which supports the hose so it's not just flopping all over the place. I also made this custom oil drain here on the bottom of the turbocharger. It is a 3/4 inch size drain pipe that is leaving the turbo at roughly 45 degrees. And then on top of the turbo, we have this fitting right here, which is for the oil feed line. It comes off at a 90-degree right off the turbo using a banjo bolt setup. If we were to come off the turbo straight with a feed line, it would hit the flange in the turbo manifold. So using this helps us get away from that stuff. These kinds of fittings are easy to find. You just search up 90-degree turbo oil feed fitting. We are also going to use these braided water lines right here for the turbo. They're going to supply the turbo with coolant, and they go to either side just like that. I have used these in the past on different turbo setups, and they work pretty well. There is a Teflon hose inside of here, which has a very high heat resistance. They're going to mount with a banjo bolt like this, and they just thread right into the turbo, like that. When it comes to buying things like this, these water lines, your turbo feed fitting and drain, you got to make sure you know the sizes of your turbocharger. Depending what turbo you buy, the holes will be different sizes. For here, the feed, the drain, all that stuff is all different. So you got to make sure you know your turbo specifications before you order certain fittings. At the very back of the turbo, where the downpipe mounts, I'm using these copper-plated studs with lock nuts. I personally recommend you to get a turbo with a V-band flange back here. I also went ahead and I got this flange machined down by 5 millimeters because it was really thick and it was just messing with the clearances of certain items when it comes to mounting on the car. Here we have an oil pan from an E39 model BMW, simply because it has a much better baffle from factory compared to the E46 one, which looks like this. This should be a direct install onto the E46. I also have a tube welded to it for the oil return of the turbo, which we will discuss here in a second. Whenever you have your oil pan removed, I highly recommend you to replace your oil pump chain bare minimum, as the oil pump chain for the M52 TU and the M54 engine, they like to stretch and become pretty loose. That can snap your oil pump shaft, worst case scenario. So I like to always replace the oil pump chain. Now, if you don't have the timing cover removed, you can go ahead and get a split chain like this that uses a master link. It is from the company called iOS, and there is the part number right there. If you are skeptical of a split chain like this and are worried of the master link separating, I would not be too concerned, because I've used this exact chain in multiple scenarios and have had no issues, along with loads of other people out there this chain works perfect. You want to make sure you face the locking clip here in the proper direction. That is pretty much it. The reason I opt for those split chains is because in scenarios like this, as you can see, the engine is still assembled on the top end and the block, the timing cover still attached, crank pulley still on. The oil pump chain is behind the timing cover, up in there. So here you can see the amount of slack these chains can get. This is the original oil pump chain on the M52TU. You can see that amount of play right there. So simply, you just grind off these nubs, remove the chain, then run up the split chain, link it together. I also like to safety wire the oil pump sprocket nut to the sprocket. That is a common practice. Some people like to tack weld the nut to the sprocket. That is also fine usually. I do not recommend you to weld the nut to the oil pump shaft. That can weaken the metal due to heat. This oil pump chain is also behind the primary timing chain. So unless you plan on refreshing everything in there, going with the split chain is the answer. Okay, so here we are with the brand new chain and safety wire installed. Now look at this difference. Look at how much more tension is on this chain. That is why I suggest to replace the chain bare minimum whenever the oil pan is off. Right here is that master link clip. You can see how it's positioned. This engine spins clockwise. You want to put the closed end of the clip towards the direction of travel. You can see right here is the open side, and right here is the closed side. You want to face the closed side towards the direction of travel. And also the safety wire, as you can see, I have it ran through the sprocket. Now, you can buy a pre-drilled nut. I just like to drill my own. That's usually what I do. I also bought a spool of safety wire. This will last you quite a while. Basically, once your nut is drilled, you run the wire through it, wrap it tightly, and then you're going to pull the wire towards the direction of tightening for the nut. This is a reverse threaded nut, so turning it to the left is going to tighten it. So once this is torqued to spec, I put them to around 18 foot-pounds, and I do use some red thread locker on the nut and shaft. Once that's tightened, run the safety wire, wrap it real tight like that, and then pull it towards the direction of tightening, go through the sprocket, wrap it again, and then I tuck the secondary wrap underneath the primary wrap, so there's no chance of it coming undone. Doing this is going to keep constant tension on the nut at all times. This method right here is also used by aviation mechanics for aircraft to keep fasteners from loosening. And there we go, we now have the oil pan installed. You can see this E39 oil pan actually has more clearance than the E46 one did, especially back here, between the subframe and above the subframe. It is also a direct swap and uses all the same bolts and the oil level sensor and also the dipstick tube. Everything just directly swaps onto it. Now this right here is my oil drain for the turbocharger. We will be talking about that here in a little bit. Okay, and here we are. We have the turbo now installed. We used copper nuts up there. They are a locking nut made for exhaust. You want to use something similar, if not the same, because you do not want your turbocharger getting loose after a few heat cycles. It is an absolute pain to get the front two nuts whenever everything is installed down here. So you want to make sure you have it tight and right the first time around. Right here is the wastegate. If you're going to install your wastegate in the same orientation, you want to install the cross brace that runs across the car and ties to the subframe. You want to mount it up to make sure everything's going to clear properly before you make things permanent. Once again, there is the boost reference hose going to the wastegate. And then back here behind the wastegate, you can see my turbo drain hose. From the turbo the whole way to the pan, it is completely 3/4 inch. That is a huge drain, which is exactly what you want. 5/8 can also suffice, but I wanted to go 3/4 the whole way down. Now, when it comes to the pan right here, you can see how the hose enters the pan at an angle. That is very important. Here is my example. Here's the fitting. Let's say you just weld it flat to the oil pan. Do you see that? If you do that, that will turn into an uphill path that oil must take to return to the pan. So you want to cut your fittings at an angle so they are like this on the oil pan. Because if you do this, that is not going to drain properly at all. You will have oil backing up in your drain hose, and it will cause your turbo to smoke, okay? So you want to make sure you're entering the pan at an immediate angle at the pan surface. This fitting is roughly 47 degrees. As you can see, this is flat, so I have it like that much off of the pan surface to the hose. When it comes to gravity draining, like we're doing here, there's going to be 4 key things you must take in consideration. Those 4 things are going to be the size of your drain, the angle of your drain, the height of your turbo, and how well your crankcase is ventilated, okay? As you can see, this SPA turbo manifold has a turbo pretty high. The bottom of the turbo is roughly 4 inches above the oil pan flange surface, so it's way up there. That is a good thing. The size of the drain is 3/4, that's good. The angle is nice and gradual, it shoots down. So we have 3 out of the 4 things. Proper size, proper angle, good height of the turbo in relation to the oil level. Now, when it comes to ventilation, that is also very important, because if the crankcase, the engine, is not ventilated properly, whenever it is running, you can have crankcase pressure in this drain, and that will cause oil to back up. Oil can not drain freely, and it will back up and go into the turbo, causing it to smoke and burn. Okay, so now looking at a different angle of this drain, you can see how it runs down, and you can also see this brass fitting right here. That is a T fitting. Right here it is. So we have 3/4 here, here, and the top part of this T, that is 5/8. Simply because fitting a 3/4 inch hose up through there was challenging, so 5/8 it is. It's also large enough. That hose right there is a vent to atmosphere hose. That is going to help keep equal pressure in this gravity drain. You do not see this commonly with these bottom mount turbo setups because a lot of people do not know about it, and or their hose is too short. I have a long hose to fit this in here. This right here is the same concept as a vent pipe to the plumbing of your home. Your vent pipe usually runs the whole way up and exits the roof of your house or buildings, so fluids can drain properly throughout the plumbing work. Another reason why I've added this is because whenever you're gravity draining like this, let's say you are driving the car hard, and the roads you're driving are very windy, dips, curves, you're going to have oil sloshing around in this oil pan. So oil may walk up this line some, but let's say you're hitting a very steep angle in the road or something, and oil is starting to come up into here. This being vented atmosphere is going to be a very easy pathway for oil to take. If given the chance it wants to run up this line, it will just take this path. This goes the whole way up by the valve cover. I will show you where it ends up. But yeah, it is a simple vent to atmosphere hose. It also acts as an expansion hose for oil to go if it has to. Now, as you can see, I have my oil returning roughly 2 inches above the drain plug, and that is okay, because the turbo is so high and the drain is so large and the angles are appropriate, it should drain totally fine, no problems. Most people will tell you you want to go as high as possible in the oil pan, like way up here, almost right at the flange. So, if you have this oil pan removed and you fill it with water or any liquid, 7 quarts, that is the oil capacity of these engines, 7 quarts of liquid is the whole way up at this oil pan flange anyway. So no matter how high you go in the pan, you are always into the oil level. There are people out there who have successfully even drained their turbos to the oil drain plug down here, and that is the lowest point of the pan, obviously. I'm just trying to make a point here that the height isn't that important as long as everything else is proper. And here you can see the inlet to the turbocharger right there, and right there is the outlet. Goes right over the subframe. It's tight, but it fits. We will have intercooler piping, leaving that coupler, and then it will come underneath the air conditioning compressor, and then it's going to go right there to the intercooler. I already have the intercooler piping made up. I'll be showing it in a next video. You can also see that black hose. That is one of the water lines. I will be showing that in a different video as well. One will go to the block drain, right there. The other one will go to the lower radiator hose. But yeah, that is where the turbo ends up down here. Now the intake of the turbo is going to run up through there. So it's going to avoid that water pipe. It looks close in this video, but it's pretty far away. The primary intake for the turbocharger is going to end up right in here. On the passenger side, you can fit 3-inch the whole way down to the turbo. Nice big intake, and it's going to fit nice. This hose right here is that vent line for the oil drain. It ends up right here. This vent right here is actually made for a boat. It's just a simple stainless steel mesh. The reason why I'm not using a traditional filter up here is because those kinds of filters, the media they're made of can clog up pretty quickly when exposed to oil vapor. And there we have it. That is all for today's video. In the next one, we're going to talk about this custom downpipe that we built for the turbocharger project and the rest of the exhaust. We will also be discussing possibly the intercooler piping and the intercooler, stuff like that. So yeah, until then, I'll see you guys in the next video. Catch you later.